Hi, in this session, let's study three-dimensional solids. As an example, a machine part is a 3D solid. In general, geometrical solids are classified as polyhedron and solids of revolution. A polyhedron solid has many heads or sides, known as planes or faces. Regular polyhedron has equal and regular planes. Some of the common types are tetrahedron, cube, prism, and pyramids. In tetrahedrons, all faces and base are equilateral triangular faces. A cube has 6 identical faces, each being a square. Prisms are named according to the shape of their bases as triangular, square, pentagon, and hexagon. A pyramid is a polyhedron having many-sided planes, base at one end and a point or vertex at the other end. The base of the pyramid may be in different shapes. The other category is solids of revolution, which are generated by revolving 2D planar figures like a rectangle or right-angled triangle about its sides. Most common forms used in engineering drawings are cylinders and cones. A cylinder is a solid of revolution obtained when a rectangle is revolved about one of its sides. A cone is generated by revolution of a right-angled triangle having a circular base and a vertex. So, we have discussed the concept of solids. Now we'll see how the solids are projected with reference to the orientation of their axis. Different possibilities of the orientation of the axis include being perpendicular to one of the reference planes and inclined to the other, or being parallel or inclined to both the reference planes. First, we'll illustrate the case where a regular pentagonal prism of side 50 mm and height 120 mm is resting on HP with its axis perpendicular to HP and parallel to VP. It has two faces A, B, C, D, E and P, Q, R, S, T. Here, its top view will appear as a regular pentagon on HP. Let's draw its projections. For this, first draw a horizontal reference line XY. Below the line XY, we'll draw top view, which is a pentagon with side 50 mm. Observe that top face A, B, C, D, E is visible and base P, Q, R, S, T hidden. The side EA makes an angle of 45 degrees with the line XY. Now, the vertices of the pentagon are joined to the midpoints of the opposite sides to obtain the center O of the prism. From the endpoints of the pentagon, generate vertical projectors. Their intersection points with line XY form the base of the prism. Now, extend projector from the center O long enough to be able to represent 120 mm height of the prism. Then draw line X dash Y dash parallel to XY at a distance of 120 mm. After that, project the base points vertically to intersect line X dash Y dash at points A dash, B dash, C dash, D dash and E dash. Here A dash, B dash, C dash, D dash, E dash is the top face of the prism in front view. So here we are with a complete view of the given pentagonal prism. Well, let's carry on the discussion of the projections of solids. We'll study the case in which a right pentagonal prism is resting on HP with its axis parallel to both HP and VP. As the axis is parallel to both the planes, it does not intersect either of them. However, the projection onto AVP gives true shape and size of the prism. So, we'll draw the side view first, then top and front views by projecting the lines from side view. First, let's generate a pentagon inclined at 30 degrees with XY. This is how the prism will appear from side view. Now, to construct the front view, project the corner points of the pentagon parallel to XY. The prism is resting on HP with its edge A', B' of length 150 mm coinciding with line XY. Draw vertical lines from points A', B' above XY to intersect the projectors drawn from the side view at Q', T', R', S' and also at B', E', C' and D'. This completes the front view of the prism. Observe the hidden line E', T' represented as dotted line. Consider a vertical center line MN between the front and the side view. Extend vertical projectors from A' and P' below line XY. Project the corner points from side view onto XY. From these intersecting points on XY, draw lines at 45 degrees to meet line MN. These lines are further extended horizontally parallel to XY, meeting the projectors drawn from front view. Mark the intersecting points as T, S, P, Q, R and E, D, A, B, C. Here, the line AB is hidden. This will form the top view of the prism. Take a look at the entire construction of the prism. Let's crack another construction problem. A regular pentagonal prism of side 60 mm and length 120 mm is resting on HP with its axis inclined at 30 degrees to VP and parallel to HP. So, first draw a reference line XY. Now, first let's assume that axis of the prism is perpendicular to VP and draw the front view with one of its sides lying on XY. Next, for the top view, the projectors are drawn from front view below XY. A horizontal line parallel to XY is drawn to intersect the vertical projectors at points P, Q, T, R, S. Then, at a distance of 120 mm, draw a horizontal line that cuts the vertical projectors at A, B, E, C, D. This develops the prism. Here, observe the lines QB and RC are hidden lines. Now, it's time to create 30 degrees inclination. For that, draw an inclined line at 30 degrees to XY. It represents the axis of the prism. Copy transformed prism from its top view onto this line. So, what will be the front view in this position? It will be formed by projecting the corner points of the inclined top view vertically above the line XY. Then, the horizontal lines are produced from the corner points of the previous front view to intersect the above vertical lines. Joining these points in a proper sequence gives the required front view. So friends, in this session we learned how to project solids when their axis is positioned in various orientations with HP and VP.
Hello, dear students. Now we will turn to another problem. The problem is to generate the projections of the hexagonal pyramid, which is 40 mm in base, axis length is 75 mm and has a slant edge on ground making an angle of 45 degrees with VP. First, we will draw the XY line. Now let's start with the top view. Draw a 40 mm hexagon in top view. Label all the points as A, B, C, D, E, F and O and connect all the points to the center O. So now we are ready with the top view. For the construction of the pyramid, we will draw projections of this base hexagon on line XY. After that, label the points where the projectors are touching XY as A', B', C', D', E', F'. Locate the point O' at height 75 mm from XY line on the vertical center line and connect all the points to the center O'. Now we will consider the elevation of the pyramid such that the apex is on the XY line. For this, take the length of line A', O' and mark it on the XY line. Similarly, taking the measurement from the previous elevation, locate point D' from A' and O' by drawing arcs. Then join points A', D' and O'. Now take positions of the other points, locate them on line A', D'. Connecting each point to the apex O', we are ready with the complete elevation. So let's generate its projection. Draw the projectors in downward direction. Also, take the projections from the previous plan. Locate and connect the intersecting points as A, B, C, D, E and F. See, the base is visible from the top. We will be getting the hexagonal base. Lines crossing base AO, BO and FO will be dotted as they are hidden. Now consider the rotation of the plan by 45 degree. where observer is nearer to the apex. For this, draw line AO making an angle of 45 degrees to line XY. Transfer the distances of all points from previous plan onto the new plan for rest of the edges of the pyramid. Now let's draw its projection. Take the projection from the elevation and plan. Locate the points where projectors crosses each other as A dash, B dash, C dash, D dash, E dash, F dash and O dash. See the outer boundary of the pyramid by joining points A dash, F dash, E dash, D dash, C dash and O dash. Draw dotted lines A dash, B dash and B dash, C dash as they are hidden. Join other points with solid lines and slant edge B dash O dash is dotted as it is hidden.